Hi friends, my name is Maruthi. In this session, we will learn about three things. What is Hadoop, where the Hadoop, why the Hadoop. Okay, first, what is Hadoop? Hadoop is just framework which will allows for a distributed processing of a large data sets across clusters of commodity hardware using simple programming model called MapReduce. A large data sets in the means very huge amount of data. What whatever the thing it is structured or unstructured or semi-structured, whatever the type of data which is in huge means in terabytes in petabytes we can process with the help of Hadoop that huge amount of data which is available in petabytes terabytes like that data. And one more thing, the main challenge with big data is not to store the data and is process and it is to process the data. Process in the sense reading and writing on the data. Okay, with the help of this Hadoop we can easily process that huge amount of data also. For example, we'll see with one example. I'm having, for example, one XYZ company is there. XYZ company is there. Okay, it is having some systems to store. It is data and it is systems to store the data. First, he got 4 GB of, so you can use a system RDBMS, traditional HDBMS, to store that system. Okay, after uh, in next year he got 8 GB of data. The data is increased continuously, so he got 8 GB. So you can use no problem. Again with a HDBMS you can store and process the data. And after few years he got some 10 terabytes. So it is not possible to store and it is not possible with RDBMS. So he is using some file systems. One file system is enough to store this 10 terabytes of data. After few years he got 50 petabytes. So it is not possible to store in single file system. So he has to use distributed file systems. So distributed file system. So actually this Hadoop is having two things. One is to store the data and another one is to process the data. To store the data it is having its own DFS, distributed file systems. We are calling it as HDFS, Hadoop distributed file system. And to process the data it is having some programming model, simple programming model called MapReduce. In MapReduce we are using that program we are writing programs in Java in MapReduce. So in this type of situations, Hadoop is using means the data is continuously increasing. So it is not possible with traditional RDBMS. So we are moving forward with Hadoop. Okay. Okay. Next we'll see what are the tools are require available in Hadoop ecosystem, which type of tools and which conditions we are using, uh, which type of tools are using on which conditions, like to write a program to write a MapReduce jobs we are using core Java is enough. Okay, like that we'll see next slide. We'll take one database. With the help of data lifecycle management we'll move forward which tools are required in which conditions on Hadoop ecosystem. Okay, actually this data lifecycle management is having 5 stages. One is a data source. Okay, here I am having three sources: uh, data source 1, data source 2, and data source 3. Okay, after data source stage, so we have to capture the data from source. So capturing stage, after capture the data we have to store somewhere the data. So storage, after storage we have to process. We are going to process with the help of some programs on the top of the actual data. We are applying some programming models. So this is processing stage. After processing we will get some output. So for that output, visualization of output with the help of some graphs, some tables, like that. This is a visualization of output stage. Okay, first I'm taking this data source 1 as RDBMS. So I'm getting data from one source. First source is RDBMS. So next second stage is from app server. Also I'm getting some uh, data from SAP systems. I'm getting some data. So from different sources I'm getting different types of data. After that I capture that data and everything. After that I stored in distributed file systems. The data has been stored fine. Next, some I'm applying some business logic on the top of this actual data which is available in DFS. So I'm applying some uh, business logic. So exactly I will get some output. So some output. After that I'm using we can use some reporting tools like business objects and microstrategy, cognos, like that. After this output we can use some ETL tools also like informatica. So to visualize our outputs we can use some reporting tools like that. We'll see actually in this storage and processing. To store and process we are using this Hadoop. In these two stages we are using our Hadoop. Actually this is main our Hadoop. In these two stages we are using our Hadoop. Okay, it is having its own, Hadoop is having its own DFS, so we are calling it as HDFS storage. For storage purpose we are having file system that is called HDFS, Hadoop file system. And to process we are having some programming model called MapReduce. Okay, this MapReduce jumps we are writing in Java. Okay, this MapReduce program we are writing in Java. So for to write this MapReduce program, so we required core Java. Core Java is enough for not no need advanced Java and extra stuff. So and without core Java also we can process this data. We are having some abstraction language, query language called Hive. In this processing stage we are having Hive. Hive is a query language like SQL. We are calling it as a Hive query language, and it is a abstraction language. We are applying, we are writing queries like SQL, and Hive internally it will create some MapReduce jobs, and it will apply on the top of this DFS, and we will get output. So after Hive we are having one more Pig. Pig is a scripting language. So This is also we are writing code in pig, and we are applying on the top of our HDFS, and this pig interpreter is internally creates map reduce jobs, and it will give output. This is about hive and pig. So first we'll come here. I'm getting source from RDBMS. So I have to take this I have to capture this RDBMS with the help of Scoob, Hadoop. With the help of Scoob, I can take this source data from RDBMS to HDFS. Actually, this is SQL to Hadoop. So SQL to Hadoop. This is called one tool is there called Scoob. So Scoob is required here to get the database to get the data from RDBMS to Hadoop, and as usual from Hadoop to we can export the data to RDBMS, and we can import the data from Hadoop. It is SQL to Hadoop. So after this SQ and OOP we are taking as Scoob. The name is the tool name is Scoob. So from second data source, that is from app server. So here we are using some tool called Flume. So we have to learn Flume to get the data from app server to HDFS. So here we have to learn Scoob to get the data from RDBMS to Hadoop, and here it has some SAP system. It is it is related to some SAP. They can export data to Hadoop. No need here anything. It is no need means it is under SAP systems only. One tool is there. They can capture the data. Okay. After capturing, we stored in HDFS, and we can apply some MapReduce jobs with the help of a Hive, Pig, and MapReduce in core Java, and we will get some output to here, and we can visualize that reporting tools are other. So for storage and processing, we are using Hadoop. With Hadoop, we are learning now Hive, Pig, core Java, and Flume, Scoop are required. And one more thing, main thing is this Hadoop is sequential data access. Okay, not random access. Actually, RDBMS is random access, but here this is sequential access. So on the top of Hadoop, to access the random access, for example, will sequential access means I'm having some file, so I'm having some data, this like this is I'm having some data in Hadoop, and I have to get this last this middle record. I want this middle record only, but in here it is some sequential data access. It is a sequential data access. So to get this middle record, I have to read all this record up to here. Up to here I have to read all the records, but whereas in traditional RDBMS it is the random access. We will I'm having some table, and like this, select star from id where id equals to 5, like that I will get a random access. Okay, on the top of this Hadoop we can get random access also with the help of some NoSQL database, some NoSQL databases. NoSQL database means not only SQL. Okay, some having MongoDB, HBase, like that we are having some NoSQL database. In Hadoop, we are using this HBase to get the random access on the top of Hadoop. So we have to learn this HBase also. And one more thing is that called Spark. To process the data, we're having one language called Spark. One Spark like MapReduce, but it is more faster than MapReduce. It is 4 times better than MapReduce. This Spark. Spark is also to process the data. We are using Spark. So now we got means in which stage, which tool we have to use in a Hadoop ecosystem, like that. Now we'll see. So now we got understood what is MapReduce. MapReduce is simple programming model to retrieve and analyze the data. We are applying some jobs on the top of actual data so that we will get some output. So the challenge the challenge with big data is not to store and to read and write the data. See, three V's of big data. Actually, the three V's of big data is nothing but velocity. Three V's are one V is velocity and variety, and volume. Okay, means volume in the sense when huge in terabytes, in petabytes, we can process this data with the help of Hadoop. Okay, nowadays big data, this Facebook generates 500 terabytes. For example, that flight engine can generate 10 terabytes of data for every half an hour, and Facebook it is generating 500 terabytes for every day. So this type of huge amount of data in volume, it is very large. And variety, which whatever the thing, it is a structure, it may be structured, it may be unstructured, it may be semi structured. So we can process with the help of Hadoop. We can store and we can process. And velocity, some app servers it will generate very fast, means continuously, that some that app servers will generate some logs. So that type of data also we can store and we can process with the help of Hadoop. So actually, data sources, from where we are getting data. Data sources are mission generated, and user generated. Mission generated, some server logs, RFID, sensors, scanners, like that, mail logs, like that, some mission generate. User generated, some transactions, social networking, media, searches, emails, like that. Already we got this. What is the use of Hadoop? With the help of Hadoop, we can store the data in DFS, and we can process with a MapReduce. We can store the data which is structured, semi-structured, and unstructured. We can store the data in large amount, in terabytes, in petabytes. And the main slogan is Hadoop, write once and read many times. So these companies nowadays using Hadoop. Facebook, IBM, HP, eBay, Amazon, Flipkart, Yahoo. How much data? Already we got this Facebook generating 500 terabytes per day, Yahoo generating 170 petabytes, eBay generating over 6 petabytes. And getting this data to process becomes bottleneck. Bottleneck in the sense processing will slow, means whenever the data is going to increase in volume, and the processing automatically it will get down with some other systems. So but if with the Hadoop there is no issue. we can process easily. Why Hadoop? Why we have to use Hadoop? Means we can store unlimited data in terabytes, petabytes. We can process any type of data. It may be structured, semi-structured, unstructured. It is using commodity hardware. This is the main thing. What is commodity hardware? Commodity hardware is in the sense very cheap systems. Like nowadays in market, we are getting one 1 terabyte of laptop. We are getting just 25,000 to 30,000 like that. So this and all very cheap hardware. So actually that system, um, that expensive systems cost is 1 terabyte of hard disk laptop is in in lakhs of amount. But we are getting this, we are using this laptop, so 25,000, 30,000, we are getting 1 terabytes of laptop. This and all very cheap. Like that hardwares only we can use in Hadoop for DFS, in distributed file system. Expensive or less. So unlimited IO channels, means we are having this DFS, no, distributed file system. If one system is having 4 IO channels, in DFS we are using 10 systems, so we will get to 40 IO channels. Because of this DFS we are getting more IO channels, unlimited IO channels, and unlimited resources. Fault tolerance in the sense, our data will not loss. Means data will not loss means, if once we store the data in Hadoop, it will give three replications. Means in three uh, places our data is available. If one system is getting crossed in DFS, and we are having another two systems to get our that data, so fault tolerance is also less. So this already was seen. Okay, this is the now today class. Okay, thank you for watching, and please subscribe my YouTube channel is Hadoop Maruthi. You just to subscribe, you will get more videos like this. Thank you for watching.